Alright, so today we'll be looking at the problem group anagrams. So given an array of strings, group anagrams together. So if we look at the input, it says eat, tea, tan, ate, gnat, and bat. And so what grouping them together means is we have to, well, first let's start off by defining what an anagram is. So an anagram is a rearrangement of characters. So for example, if we look at eat and tea and ate, they all have the same letters. E, T, A. Words that contain the same characters that are rearranged in a different manner. So as far as the groupings go, if we look at the first group, ate, eat, tea, they all have characters A, E, and T in them. So that will form one group. And then if we look at Nat and Tan, they have A and T as all the characters in there. And then final one is Bat, which is just on its own. So our goal is to essentially group all possible anagrams in a list together and then return that as a list of lists. This problem is a lot simpler than you might think, so let's just jump into the conceptual overview. Okay, so here I have the inputs from the first example, and so I'm going to walk through how we would actually do this problem. So remember, an anagram is just a word or a phrase that is formed by rearranging the letters of another word. How would we be able to go through our list and determine all the anagrams in one pass? All right, so remember the output that we had in the problem. So for example, the first list will have eat, tea, and ate. And so the simplest way that we can get all the anagrams in a particular grouping is by simply using sorting. So at least in Python, you can actually sort strings because a character has a particular value attached to it that isn't immediately obvious, but by sorting a string, it will sort it, ascending from like A, B, C, D, E. What we can do here is every single word that we come across, we can just sort it and then check if it's in our dictionary. If that sorted word is within our dictionary, then we just append the current word that we encountered to the list of that key. So it'll look something like this. So we come here to eat, and so when we sort eat, this will return. So now this is the sorted value of eat. And so what can we do with this? Well, AET will now act as a key in our dictionary, and I'll have a value of a list. And so what we'll do is, now that we have this key, we'll take eat and then just put that in the list, right? Then we come across T. So when we sort T, it'll return the same result. So it'll be AET as well. So we know that T matches this key, so then we can take the word T itself and then just append that to our list. And so this continues on and on, 8 here, and then this will be the first list. But in the meantime, we'll also encounter tan. So a tan, we sort this, sort tan, and then we return A and T. So that'll be our other. And so as we already know, there's tan, and then also nat, which sorts the same value. And then finally we have bat, which this will return ABT, ABT, because it's sorted. And then since there's no other ABT that we encounter, the answer right here is just bat. And so after everything's said and done, we'll return just these values in a list. So that's pretty much the problem. It's actually a lot simpler than you might think. The biggest bottleneck about this problem, though, is that it does use a sorting function, and so that operates in n log n. And so that does impact the runtime a little bit. So we have our runtime. So the runtime will be O of n k log k. And the reason being is because n is the length of the strings, or the inputs that we get, and k is the maximum length of a string in the inputs. And then we sort each individual string k log k times. So we're doing this all in one pass, but essentially for every single word we encounter, we have to essentially sort that entire string. That string could be greater than 3, there's no specified length for the particular string that we encounter. So we'll be sorting the entire length of that string with the sorting function, which is n log n. We'll be doing that for every single word within our list. And then space will be O of n k. And so this just represents the information stored in our final answer. And so the reason why it's nk, so you can think of it as n times k, is because n is our list and then k is the individual length of the strings. And so combining that together, we get O of n times k. So the runtime for this one is a little bit weird, but just know that whenever you incorporate a sorting function, it will immediately make your runtime around n log n. And then you have to sort of factor in like what other operations you're doing. And so because we're sorting individual words through an O of n list, that will impact the runtime just a little bit more. So it's not just n log n, we have to get a bit more specific than that. And then of course the space, since we're sorting and storing that, is also affected as well. So just keep that in mind. So hopefully this all makes sense. Now we're going to go do the coding walkthrough. Okay, so let's jump into the code. So first things first, we're going to have to establish our grouping. So we'll need a dictionary for that. So we'll just call this group, an empty dictionary. So that's what we'll be using to construct our key and value pairs and then ultimately pull all the values so we can build a list from that and then return that as our final output. So what we'll do next is just iterate through our input. So for I and strs, so strings, what are we going to do? Well, remember, we have to sort it first. So we'll just have a variable called key, and we'll just say join. We're taking a string and we're joining it. We're joining the sorted value of I. So for those of you who aren't familiar with Python, essentially we sort the function first. So we take, let's say we encounter eat. The sorted value for the string would be AET. And then join just means we're joining it into this particular value. So we take an empty string and we're joining the sorted value. So essentially it's just the sorted value alone, and that'll act as our key. So then we can just take this key and check if it's in our groups. If it is in our groups, then we can just append it to the appropriate key. So groups key append I. If it's not in our grouping, then we just add it. So then if it's not there, we need to create the value in the first place. That's pretty much it. All we have to do is just return our final results. So we will create a list, and then that list will be comprised of our groups values. So what this is saying is groups is our dictionary, and since there's key value pairs, we're calling values just pulls all the values only. We forget about the keys, and then we cast that into a list, and so that should give us a list of lists that look exactly like this. Everything was good. We have our grouping, we iterate through it once, we sort, add it to our dictionaries we need to, then return the output. So let's run this and see what we get. Okay, so that works. Now let's submit. Perfect. Runs 96.1% faster than all the other ones. So this is a pretty solid solution. Despite the sorting, since we are only doing one pass, it's still pretty minimal, at least compared to other solutions. So this is a pretty solid approach. So yeah, hopefully you learned a lot with this one, and I'll see you guys in the next one.